are intermolecular forces, right? And so going along with we're learning a language, this is basically, if I was going to translate this, the forces, these are usually attractive. The attractive forces between molecules. Oh, and I forgot to mention, I do make these Canva notes available after class. I'll put the PDF of these notes up. In case I was writing something and you didn't quite catch it, you can always look back at these notes, but please do write them down as well. All right, so we're going to study the forces between atoms. And to do this, we are going to start with the three types of matter we generally study in general chemistry. That is, we're going to talk about the gas phase, the liquid phase, and the solid phase. These are our three types of matter. And when it comes to intermolecular forces, and a lot of the times when I'm talking about intermolecular forces, I will use the abbreviation IMF because I don't want to write this whole word. So anytime you see IMF, that's intermolecular force. So for a gas, and these are atoms, and I'm going to put these little dashes. These dashes are to represent the IMF. So the interaction, the forces between gas atoms or molecules. Gases have very weak intermolecular forces. The interaction between atoms and a gas are very, very weak. In a solid, they are very strong. In a liquid, they are moderate. So when we're thinking about the forces between atoms, gases have the weakest forces. Solids have the strongest intermolecular forces. Liquids are between the two. And let's say I want to go between these different phases. So let's say I want to go from a gas to a liquid, or a liquid to a solid, or going backwards. Going from one phase to another is called a phase change. A phase change. All right. So let's say let's go from right to left. Let's say I want to go from a solid to a liquid. Well, what I need to do generally is add heat. Heat needs to go in. If I go from a liquid to a gas, I need to add heat as well. And we know this, and I'm going to go back to water as my example a lot of the times in this class. If I have an ice cube, if I want to make that liquid water, I have to add heat. If I have liquid water and I want to make that into a gas, I need to boil it. I need to add heat. Why? Well, the why of why I need to add heat is because of these intermolecular forces, right? If I want to go from strong intermolecular forces to moderate, basically what that is meaning is that I am breaking some IMFs, right? I need to break the attractive forces that are holding these molecules together in a solid. To break IMFs, you need to add energy, right? In chemistry, if I want to break an intermolecular bond, I need to add energy to break that bond. And for us, when we generally think of energy, we think of temperature. Temperature is a measurement of energy. And when I'm going from a liquid to gas, it's the same thing. I'm going from moderate intermolecular forces to weak intermolecular forces. So again, I need to break IMFs. I do that by adding energy. Let's go in reverse though. Let's say I want to go from a gas to a liquid or a liquid to a solid. Well, for that, I need to cool down my temperature, right? I need to remove heat, basically, right? If I want to make ice cubes, I stick them in the freezer. And the reason for that is the opposite of what we just talked about. I need to form intermolecular forces. So if I'm going from a gas to a liquid, I need to form new intermolecular forces. I need to form new interactions between molecules. The way I do that is I have to take some of the energy away from these molecules. When I take energy away, these molecules slow down, right? By lowering the temperature, I am saying, okay, atoms, you are now moving slower. When you are moving slower, you are going to form generally stronger bonds. And we're going to learn the why of this in like chapter 19. So we're going to learn why slowing down makes you or helps you form bonds. But for right now, just know phase changes. Going from a solid to liquid to gas, you're adding energy to break intermolecular forces. Going from a gas to a liquid to a solid, you are removing energy to form intermolecular forces. So that is our overview of intermolecular forces. Any questions about those definitions or those descriptions there?